Okay, in this video, we're going to start working on some applications that make use of some of the percent skills that we've been talking about. This first problem here, we have a student loan. To finance her education, Sarah takes out a Stafford loan for $5,000. After a year, she pays off the interest, which is 4% of the $5,000. How much does she pay? Okay, at this point, you might have some questions about understanding this whole Stafford loan thing that might help us in terms of setting this up. Generally, how a Stafford loan works is that you borrow money to go to college, but your requirement to pay back the principal, the $5,000 that you're borrowing, is delayed until you've graduated and completed your program, as long as you are willing to pay the interest accrued over that year or years that while you're in education. So we need to calculate what that 4% of $5,000 is so that Sarah can pay that back while she continues on with her schooling. So what we need to focus on is that what we're looking for is the part. We want to know what is 4% of 5,000. So I'm going to do this both ways that we discussed, the the proportion or the triangle. I'm not going to do the algebra just because I'm going to run out of space. And most students rely on one of these two. Actually, most students start with the proportion. By the end of the problems, they really like the triangle. Okay, so with this one, with the proportion method, we usually like to put 100 here to the lower right. The lower left is our whole, which in this case is the 5,000, and we are solving for the part. For the 4%, I'm going to write that as 4 over 100. So you would cross multiply and divide. In your calculator, you would put in 5,000 times 4, divide by 100. Divide by 100, and you should come up with $200. Okay. If I was doing this by the triangle method, again, my whole base is 5,000, and we're trying to figure out 4% of that. That's our rate, but I'm going to have to write my percent, 4%, as a decimal. And because these are side by side, I'm going to have to multiply those two. So you'd multiply those two in your calculator, and again, you should come up with 200. Now I want to make sure that this makes sense for us. No matter which method we use, does our outcome make sense? So when you look at this $5,000 and we're looking at 4% of 5,000, I'd want you to think, well, heck, if I was looking for 1%, I could move my decimal back 2 places because 1% is 1/100th, so I could move that back. So 1% would be 50, and I'm looking for 4. So 4 times 50, yeah, that would be 200. So that's another way. I mean, you can reason through very often and find your answer. This all worked out because we had a lot of zeros and things were rounded. Usually it's not going to be that neat. On this next one, actually, I'm going to get rid of the second question because that's a different skill there. Leon left a $6 tip for a $35 meal. What percent of the meal cost did he tip? So we want to know what his tipping rate is. We are looking for the rate. So again, we could set this up as a proportion problem. This is the blank part. We don't know what that is, but we know that $6 is the portion of, so he tipped $6 of a $35 for a $35 meal. So $6 is our part, and that's kind of confusing in terms of recognizing that that's the part. We cross multiply and divide, and we should come up with that he tipped at a little more than 17.14%, so a little more than 17%. Now again, when I'm solving my answer here, if I leave 17.14 here, that's saying that that's part of my percent ratio. When I pull it out of that ratio, I have to tack on the percent. So if I was going to do the triangle or the T, you just take the T, that's totally fine. I could put 6 as my portion over 35, and that would justify that I would divide. In my calculator, I would say 6 divided by 35, and I should also come up with the 17.14%. And again, if you're looking at that $6 out of 36, we're looking at 1/6 of that meal. 1/6 is right at about 16.6%. I know that because I like math. Most of us probably wouldn't, though. Okay, but just try to make some sense, of your outcome. Does that make sense? If you think of it, 10% of $35 would be 3.5, and this is way more, $6 is way more than 3.5, but if I double 3.5, that'd be 7. So that's kind of telling us it's not quite 20%, but it's definitely more than 10%. So now that makes sense. Okay, Sammy Sosa has 98 hits so far in the season. His batting average is .220 or 22%. How many at-bats did he have? Kind of have to have a little comfort with baseball here. First of all, don't ask me why, but baseball identifies their percentages to 3 place values. Allows them to be a little more exact, I guess. We need to recognize, Sammy Sosa had to be up at bat quite a few times to get 98 hits. So we have to recognize that the 98 hits is the portion of times that he was at bat that he actually got on, that he got on base. So when we're looking for our at-bats is the total number of times that he was at the plate. That should be much bigger than 98. So we know that this is our whole, our base. So that's going to help us getting things in the right place. 22% would be 22 over 100, but we need to recognize that we're solving for the whole. This is what we're solving for. We don't know the number of times he was at bats. 98 is the part, and I would say in this particular problem, students have a hard time not only just with this problem, but any word problem, any application problem, recognizing when they're solving for the whole. They very often confuse and put the part in place of the whole. So just make sure that you're aware of your components. So I cross multiply and divide, and I'd come up with about 445.45. So that's, we're going to have to round that to a whole number, to 445, because a decimal isn't going to make sense. He can't be at bat 45% of the time and away from it. So it's not like he's at bat and not at bat. So 445%, or total, I should say, at bats. Okay. If I did this with the triangle or my T, I would be putting 98 over, and I'd have to recognize my 22%. I could write like that as a decimal. And that justifies that I'm going to be dividing, so you would go to your calculator and just straight up divide. And you should also get 445 for that one as well. I'm hoping we can get cooking along here and do a few more of our application problems. But each of these cases, you were solving for just a simple component, either your whole, your rate, or your part here. Okay, it's going to move on and get a little more interesting now. Okay, we've got a couple more percent problems. Our first one, we have a toolbox and tools that retail for $725. And it's available to contractors for $543.75. What is the percent discount? And so I think everybody recognizes that, we're looking for the rate. So they automatically look at this and say, well, there's my whole. So they put in 725 here, 100 here. They know that we're solving for the rate, and that other number, 440 or 543.75, must be our part. So they cross multiply and they divide, and they come up with, I think you should come up with 75 or 75 here, and that'd be 75%. So let's kind of take a look at that again. A toolbox and tools retails for $725 and is available for this amount to contractors. What is the percent discount? Well, we found 75%. We're like, holy cow, the contractors get 75% discount? That's a lot off. So let's start thinking about this. We found a rate here, but what is this rate? That rate is the rate that they pay. Okay, so what happened here is they gave us information about a part, but then they asked us about the other rate. So what we'd have to do is we'd have to take 100 minus 75 to get 25% discount. Okay, now again, what I'm saying here is probably a little confusing. If you recognize that when they're reading this, they don't have to pay 100%. What we actually calculated is they pay $543. We found out that they pay 75%. That's the amount that they are responsible for. So this is the contractor rate. They only have to pay 75% because they get a 25% discount. And we took that 100 minus the 75 to find the actual answer to our problem. I'm going to go ahead and do this another way. I could look at this and say, well, I know that if they have to only pay $543.75, I can say 725 minus 543.75 is equal to 181.25. This is the amount, this is the contractor discounted amount. Contractor's discount amount, not discount rate. So I could look at that way, and so now I could set it up. I'm going to do this one with the triangle method or my T method. This is the portion that they are discounted. So I'm going to put that 181.25 over 725 and carry out a division problem here, and I'd come out with, I'm sorry, the 725 should go here, because I always put my base over to the left. I can get away with it, but I want to stay consistent for students. I put my portion divided by my base, and I would have come up with 0.25. And I can interpret that as 25% discount. Okay, this was we had a lot going on here. I did this two different ways, and so I want you to recognize that very often our percent problems have two steps. Up until now, we've only done one step. You had to either solve for the rate, the part, or the whole. Now we've got two different steps in here, and so you really have to get your bearings. And that's why I want you to go back and make sure your answer makes sense. Did you miss a step? And so when we did that, we realized we were giving them way too much of a discount, and we realized we had it flipped. I want you to recognize that here originally I found 75% contractor rate, and then we took that away from 100% to get our 25% discount rate. These two rates are called complement rates because they add up to the whole. Okay? Sometimes if you go into business, you would be looking at the discount, calculating the discount amount as well as the discount, using the discount rate. That's called different things in different business areas. So I just want you to I want you to see that there's two different components here. We had two steps. Okay, so going forward, we're going to have something similar here. Plumber Supply offers kitchen fixtures at 20% discount. What is the sale price for a sink that retails for $295? So we're like, well, there's our rate. Here's our hole. We could plug this all in. 295, 100%, 20 here. We could cross multiply and divide, and we come up with, $59. And we're like, whoa, that's a pretty darn good deal. If you think about this, what is the sale price of a sink? $59. We're going to pay $59 for a sink that originally started at $295. That's just a little turned around. We need to stop and think about this. So when we look at this, they gave us the discount, but then they asked us about the sale price. So they gave us a discount, but asked us about the other. So what we could do is we could, again, say 100 minus 20 is equal to 80%. If they're getting, if we get a 20% discount, that means we only have to pay 80% of the cost. So I'm going to solve this using that another way. So if I'll do the triangle here, and I'm going to put in 0.8, and my whole is 295, and I'm looking for the part that they have to pay. So I could go ahead and multiply that out, and I come up with 230. When I multiply these two, I come up with 236. Okay, so this is actually the sale price. This is the discount amount. Now I could have continued in this path. I could have said, well, this is the discount amount. I could have said 295 minus 59 should give me my $236. And that would have been just fine as well. Either route, but again, it was a two-step. So I want you to, step back and take a look at it. In this case, they gave us a sale price, but then they asked us about the discount rate. Whereas here, they gave us the discount rate, but then asked us about the sale price.